Hi there. Welcome to another video tutorial. In this tutorial video we will be discussing how to design and construct an IoT-based fire detection and surveillance project. This project can detect fire or flame around it, detect gas leakage and human motion. It can also show a real-time video surveillance of the things happening using the ESP32 cam installed in it. We can get alert or email notification using the IoT dashboard. We can also see this alerts to know which of the elements is being triggered. Without wasting much time, let us get into how to design this project. Please take a moment to like and subscribe to our YouTube channel to encourage us to make more videos. We begin with the schematic diagram, also known as the circuit diagram of the project design. This is built around the ESP32 CAM development board. Other modules like the flame sensor, the smoke sensor and the PIR motion sensor is connected to its PO pins. This development board is powered by a 5V DC supply. This can be any 5V source. A USB port from a laptop can even serve for this purpose. The flame sensor and the smoke sensor are connected to the ESP32 cam through their digital output pins rather than the analog output pins. Now that we are done with the circuit diagram, let us set up the IoT dashboard at Kayonmi devices for the notification prompts. This dashboard will display and send us email notification when there is a flame detected or a gas leakage detected by the project design. Please read the blog post in the description link below to know how to do this. Before the project design was soldered and assembled, it was first passed through the breadboard phase where it was replaceable testing and programming was done. All connected were first made as shown in the circuit diagram using jumper wires and the program code tested. Now, let us discuss the Arduino code for this project design. As shown here, it involves getting the needed libraries for the project code. This involves the Kayon library and the ESP32 camera library. We also included the type of ESP32 cam that we are using. In this case, the ESP32 AI Thinker. We included the Kayon login details, the username, password and the client ID details. This is very important as it allows us to log in and monitor the readings as well as get alerts of the things happening where the project design is installed. We show in this line of code, where we connected the modules like the flame sensor module, the gas sensor module and the PIR motion sensor using these next line of syntax. This would allow the microcontroller to communicate very well with the modules connected to it. The setup function shows that how we set these sensors as inputs and how to start and prep the camera for video surveillance. It is basically the camera configuration codes. Without this in the setup function, the camera module won't initialize. We used a custom function to read the sensors and send it to the Kayon IoT dashboard. The check sensor function does this effectively. Now, let us test the project design. The project has been assembled, and ESP32 cam board is encased in this bullet CCTV mold. The other sensors are connected and placed on this polyethylene wrapped plywood board. When powered on by an external 5V, the project design blinks at first as shown. It searches and connects to the pre-programmed Wi-Fi credentials and once it is connected, it blinks again. During the night mode, when there is no sunlight, if a motion is sensed, it activated the 9th time, this makes a bright LED light come on. The flame sensor would be active, so will the gas sensor module. Once the project design is online, we can connect it to his public network and stream the video surveillance locally. We begin by going to the LAN-based IP address and we can start streaming video by clicking on Start Streaming. We can see what is happening where the video is placed using any device, be it computer, mobile phones or tablets and iPads. Provided any of these devices is connected to the local area network. Also, the IoT dashboard is ready to send us email notification if any of the sensors is triggered. If there is a gas leak, we will get an alert. If there is an open flame detection, the flame sensor widget on the dashboard online will start changing color or blinking. This will be followed by an email alert. The same thing goes when it is dark and motion is sensed around the vicinity. And that is it for us on the video tutorial. Let us know in the comments section if you need any help recreating this project design. You can also reach out to us via any of our social media handles. Thank you so much and stay safe.